This is a talk about Eventbrite's development environment, and so up front I will say, for a couple of reasons, I've had to obfuscate some of this because of security concerns about what we run internally, but mostly it's pretty good. But I want to take you first back to when I joined Eventbrite in 2013. And so at this point, I was based in London. Lanyard, we'd just been acquired at Eventbrite. We still had a London office, and we were thrust into the exciting world of Eventbrite development almost without warning and without anyone really around from engineering from here to help us. And so at this point, Eventbrite was developed as a single Vagrant instance. So basically, you rolled up to Eventbrite as a new engineer, and then they went, oh great, just run this Vagrant script and it will eventually make a box that runs most of our software. Which is great, because at that point Eventbrite is also a monolith. It's basically one big code base called core, with a few extra bits around the side, but it's not particularly broken out. So this is fine-ish. And it kind of reflects what's going on here, right? Like the code base is kind of monolithic. The development environment is similarly a single VM that you can SSH into. All the commands are in one place, all the code's in one place. It's a similarly big monolith. Now the problem is, if you're in the office here, it was around, the office elsewhere at that point, it was around a 1 to 2 hour rebuild time of that box. If you were on the VPN in London, it was upwards of 12 hours sometimes, to the point where occasionally I would have to start a rebuild going and then just stop work for the day because I couldn't do any more work for the rest of the day because I hadn't finished compiling. This is obviously not great. And at the time, there were very few remote engineers at Eventbrite, which is why this happened. And as we've grown, that's become more and more of a thing. But the biggest thing that was happening as I joined, and has been happening since I joined, is that we have gone the way of a service-oriented architecture. So basically, if you're unfamiliar with this, it's taking a big monolithic code base like we have and breaking it down into more functional components. There's a bit that does payments. There's a bit that does inventory. There's a bit that does event details and so on. Like Eventbrite, you can imagine, is breakable down into a number of different components pretty easily with minimal crosstalk. But of course, doing this, while it's a great way to sort of get rid of the bad ends of the code and shape things for the better, and it's a good way to sort of clean up some stuff, it brings complexity. Deployment complexity is one, but the other complexity is requirements. Now, if you've gone from one code base to, say, 10 different code bases, and they all have very slightly different requirements files, but they all have to live on one box, that's not going to work. It might work mostly. You can get along, you can sort of pip install upgrade and sort of patch the box as you go, hoping things match, but it really doesn't work very well. And finally, I am, I think, one of very few, if not the only engineer here who runs Linux on the desktop. So I really hate running Linux VMs because I'm already running Linux. And so my personal take on this was, why am I running a VM? I'm just running Linux inside my Linux. This is pointless. And so the Docker project begins. This kind of came about so me and a former colleague of mine, Kevin Stone, were sitting down, and I was like, this Vagrant thing's really annoying. I wonder how hard it'd be to rewrite at least the core parts that I'm working on to run in Docker. At that point, I was working on very core website parts, like the main core website, a couple of very basic services. How hard can it be? So I open up our Vagrant config, reel back in horror briefly, and then finally just dive in, and there's Puppet in there, there's shell scripts, there's everything, and eventually get a Docker file together that boots up similarly another monolith and manages to run a website, and it doesn't fall over, which is, this takes about a week or two at this point. And it's like, that's a major achievement. Like, no one really thought we could get the dev done from scratch again. And so over time, it's initially a very personal project. I'm going, well, I can add on this extra stuff, and there's more of the things here. But over time, it became much more of an official thing. And so I'm going to flash forward to now, but I'm going to sort of talk to you what happened in between first. So basically, over time, what happens is Eventbrite gets a lot more complex. And part of that is, as I said before, these services, but also different data stores come into play, different kinds of libraries, that kind of stuff. And the Docker project starts to become more and more of an official thing until at some point, I think it was late 2014, I forget quite when it was, it becomes the actual official development environment we work from. So this phase transition, basically. What it ends up being is that Vagrant turns out to be almost impossible to maintain at this point. The person who maintained it has since left the company as well. And so me being still here and somewhat optimistic and positive about maintaining things means that Docker becomes quite a force. And similarly, Kevin Stone joins in a lot here as well and does a lot of work to all the nasty work of bits I didn't really care about. He fixed all those up for me, so thanks a lot. But this becomes the sort of this big development environment. And let's show a small preview. So for security reasons, the container names are all just container. If you are an Eventbrite employee, you can ask for the real version of this chart that has the real names in it. But this is a chart of all of our Docker images. Now, I was going to try and show it on one slide, but this is the actual chart of all our Docker images. It's considerably complex. There is a piece of paper about this long on my desk that I unroll to look at it, to consult occasionally. So we have 120 containers at Eventbrite, and that's pretty much all of these things here. That includes the interim ones. So for example, we have a base image that everything comes from, then like a language base like Python, and then ones hanging off that. So that includes those, but as you can see, most of the containers are end nodes, they're leafs. They are their own contained thing. They are a core part of the site's functionality. And so that's quite a lot of containers, it turns out. And some of the Docker tools by themselves don't really cope terribly well with that many containers. And particularly if you're thinking about like 1 or 2 years ago when things like Docker Compose was very young, if not even existent at that point. Docker itself didn't have a lot of the functionality we know today. Things like the networking stack had not been improved. Things like build time environment variables were merely a glimmer in somebody's eye. So I want to talk a little bit about some of those problems of the core Docker that shaped how we run Docker at Eventbrite for development and what we did about them. So first of all, the biggest consideration and the very first roadblock I hit was SSH keys. So for security reasons, which I whole recommend you do, at Eventbrite, everybody has their own personal SSH key to GitHub, to servers or whatever, that's revocable per user. So when somebody leaves, we can revoke their key, job's done. There's no shared keys anywhere because there's a security risk. And so I can't just have a Docker file that has a base shared SSH key for checking things out. That's not going to work. And so I have to try and contrive a way to take the credentials of somebody from their personal machine into the Docker build environment. Now, for those who aren't familiar, the Docker runtime environment, you can pass in environment variables, you can mount things as volumes, you can do exposed ports. The Docker build environment, none of that is possible. It's very, very isolated. And so getting stuff into the build environment is nigh on impossible. And I was stumped for like a week or two about this and was almost ready to give in when a horrible, horrible idea struck me that we still use today. So the one thing you can see from a build, so when Docker builds an image, it basically launches a container with the image you're basing it from, and then just runs commands in that container. So it's a container like any other Docker container, which means it has network access. In particular, the gateway that any Docker container sees is the IP address of the host machine. So, it might be like 10 dot something, but like that address is the machine that everything's being hosted on's actual address. Which means that the one thing you can rely on from build container is looking up ports on the host. And so what our environment does is it takes SOCAT, it takes the SSH agent Unix socket, forwards it to a TCP socket, and then in the build environment, another SOCAT instance forwards the TCP socket into a local Unix socket, and nothing is ever the wiser. And so the SSH credentials are just bridged across this network gap transparently, and it works surprisingly well and has continued to work for like 2 years now. It's slightly horrific, and I keep trying to have a way to make core Docker do this, but it keeps proving to be very difficult. But it works in the meantime. And part of all this is when you run Docker at Eventbrite, we have a project called Tug internally. This is like kind of our Docker wrapper and runtime and sort of controlling instance. It does things like dependencies. It does things like this. So Tug in particular manages running SOCAT with this forwarding enabled every time a container gets built. And does other things as well. I'll come into a second. So the other thing that hit us pretty quickly is garbage collection. So core Docker has no built-in garbage collection of old images or old containers, partially because there's no real agreed idea of what is an old container or an old image. But as far as we're concerned, if an image is unnamed, so in Docker you can basically, as you replace images, the old ones, it's like a git tag, it sort of jumps across the image versions. The old ones just have an ID, they don't have a name. And so the old ones end up unnamed, and we take that to mean that they're basically useless. But like for us, you saw that graph, and when Docker builds images, it makes a new image layer for every single line in your Docker file, which means that a completely fresh build of Eventbrite is over 1,000 different image layers that all get combined in different ways. So you can imagine that it's very easy for that to spiral out of control into way more image layers and old containers and all of this stuff. And on top of that, remember that I'm pretty much the only Linux user, so everyone else is running this on a VM on their Mac, because you can't run Docker natively quite yet, but it's being worked on. And so they're running on a virtual machine that has much less free disk space, usually like 30, 40 gigs, whereas I have like a whole load of space left. And that means that it's very easy to run out of space, and when you do, even getting into the machine become a problem. So we had to sort of take from some existing garbage collection scripts, write a bit more, a few aggressive things of our own, because we know that full build tree. We know exactly what we want, so we can have the build tree informs some of the pruning we do, but that was one of the big issues as well. And then the main problem comes of a 120 component site, is that no one here needs to run all of that, right? Nobody here is working on the whole of Eventbrite. We're all small teams working on sort of much more focused components at once. And that means that we need a way of deciding what to run. Like, what is the core of Eventbrite and what is optional? And if you ask different teams, they'll all claim that their thing is very core to Eventbrite and everything else is optional. And so deciding on a particular combination of, no, these things really are very important. We can do without the payment stuff, right? In development, you can turn off the payments part and just do free events. It still works. And if you're working on something that doesn't involve payments, why would you want that? But payments is kind of a cool part. And so all these different things happen. And out of that grew a thing we call profiles. So profiles are basically sort of a subset of that graph that we say, these are the important parts. We have ones called light, which literally just runs Eventbrite in basically scraping buyer mode, like the bare minimum of services to show the website, to render it, to do things, a couple of things like it can't send email, for example. It can't do background tasks, but it will show you and do stuff in the basic experience. And then each different team often has their own customized ones for their particular task. And then there's more general ones, like there's a sort of a tidy, which is a step up from light, which is sort of like, it can do payments now, it can do background tasks, it's a bit more fully featured. And then there's a full, which is most of the stuff that isn't like data warehousing or anything, like just nearly all of the core components of Eventbrite are just run. And that can often hit a RAM limit on some machines, so that can be an issue. Now, let's see. Okay, I did this out of order. This one first. So the other thing Docker does that particularly annoys me, and this is kind of a personal bugbear, is that for a very long time Docker was like, no, there is one Docker file. It is at the root of your repository. That is how Docker files work. And I was like, but we have images that span multiple repositories. We have repositories that have multiple images. This doesn't mesh very well. And recent versions of Docker do let you specify a custom Docker file, which is a massive improvement. But we still have the problem of some of our Docker images pull from multiple Git repositories that are different. And so one thing we have that's unusual is a big centralized Docker repository. It's called docker-dev. It contains the Docker file and extra meta information for every one of the containers I showed you in that previous slide. It has some of the features it has. There's pre-build scripts, which do things like, which are very important, like copy files over. So because the Docker files are outside of their host repositories, by default, when you try and build them, it can't see any of the files. Because like Docker goes, well, I'm in this directory, there's a Docker file in here and nothing else. I guess nothing to send to the build image. And so the pre-build script is how you sort of scoop up code from other repos. And you specify it by Git repo. It sort of finds them on your machine. It scoops up code, puts it in the build directory temporarily, starts the build, and deletes it again. So that's quite a nice feature. There's another file called a tug.yaml in that directory, and that does things like specifying dependencies, which I'll get to in a little bit here. But that's kind of like, oh, this image depends on this one to run, or to build this image needs the other one available, and that kind of stuff. And then finally, on top of all of that, again, Tug, our sort of project for managing this stuff, just manages that whole process. And when you say tug build, and you can say an image, you can say a profile. So I can say tug build profile, and it will find all the images in that profile. Then it goes, finds the whole tree of dependencies. It works out all the dependencies of the images. It then dependency sorts them. So the very base one is at the beginning. It's topological sort, actually. And then just runs through the build in order, which is the quickest way we can do it. And that's a pretty decent way of doing it. Having everything in one repository is quite nice because we have one centralized place for this is where our development build scripts live. Like, these people manage it and commit to it. You can easily look at the Git history and see what's changed in that development section. So I quite like that separation of concerns of here's the code, here's how it's deployed for developers. And of course, our ops team have a separate repository for our main site, which is Puppet based and not Docker based, which has all their Puppet files. So like 3 different concerns there. Now, the one thing, and I promised somebody when I first started the project, I said, don't worry, your long vagrant rebuild times are over. In the future, it will take 5 minutes or less to rebuild everything from scratch. And anyone who works in engineering here will realize that's not quite happened yet. In particular, my goal was to have it be so quick because Docker has image caching, right? So the way Docker caching works is if your Docker file doesn't change, it sort of SHA hashes. I think it might be, it does some kind of hash on each line. And as long as the line hasn't changed, it just uses the previous layer. So you have a Docker file, and you change the very last line and rebuild it, it goes and then does just the last step, and then it's done. So that's super quick. Now the problem is that works well at small scale, but you saw that hierarchical chart. Our Python base image is 2 or 3 ancestors up from some of the other images we're doing. And so if you change like a core Python requirement that we have, that means rebuilding the Python image, then rebuilding all the other images below it, and rebuilding all ones below them, and it sort of cascades down. And that's really not great. And so the way around this is shipping images. And this is something I'm working on right now, actually. My current project here is to make this happen. Because what you can do is Docker images are meant to be predictable. The whole point of a Docker file is this is a reproducible build. The same file results in the same image every time. And this means that we can have some build servers just build everything continuously whenever a Git commit comes in with that project, like, payment stuff changed, rebuild the payment containers. And then the servers take all that stuff, they push it all up to a Docker image registry, and then developers can just go tug pull profile, and it goes, and it connects the registry and just sucks down all the images. This is particularly important because rebuilding in some of our remote offices, for example in Argentina, in Mendoza, where we have an office, can still take 5 hours, which is way too long. And so the hope is that by having these, images pre-built, most people will just be able to go, I want the newest version of our core container, tug pull core. Oh, there it is, done. Rather than having to basically have every single developer have all their machines just rebuilding the same thing. Like, imagine the wasted potential of every machine here rebuilding the same container time and again. So that's the current project we're working on. And there's some future plans as well around this stuff. I sort of discuss how they play into the overall thing. So first of all, that image registry I talked about. So Docker image registries, so Amazon have a hosted service, for example, for this stuff. You can make your own with a Docker container, surprise. But also, you can have mirrors as well. So I think one of the plans we're looking into is having a mirror of these images in each of our offices. So we have a office in Nashville, we have an office in Mendoza, Argentina. I often work out the London office every so often. So just have some way of, like, overnight when the bandwidth isn't being used, just slurping down all those images that people want. And then so when you try and get them, they're on the local network. Because, even with images, if there's 20 people trying to get an image over a small link, it's not going to go terribly well. It's still quite slow. The other thing I want to look at is better network management. So pretty much all of our containers and our design of the way our stuff is written is pre-Docker's network rewrite. So for those who don't know about it, Docker rewrote their networking, I think it was in the latest release, to be more of a software-defined networking thing. So you can make virtual networks, things can see each other and discover each other, you can route them, they can route them cross-machine, it's great. But none of that existed when we had it. And so we have a series of rather ugly hacks to make things like Zookeeper work inside our stack. So it'd be nice to sort of take another angle at that and work on using the more native Docker stuff. And the other thing that I always wanted with containers that we haven't got to yet is shared or remote containers. So some of the parts of Eventbrite are pretty static, and while you need them to run the site, you don't need them to be for you specifically or need them to be very particularly efficient. So the idea here is that there are some of those big containers that have a lot of RAM usage. We can just offload to a machine somewhere in the office, and then your development machine can just go connect to those, because now Docker can do this. Can just network to those ones, have it happen transparently, and have everything work. And then people's laptops with their slim amounts of RAM are much happier at that point. That's a long way off, and it's a very experimental idea, but it's something that I really would like to look into for it's not thin client, but it has some of the benefits of you only need 1 gigabyte of RAM now to run the site. And finally, container startup. Starting a tidy or full copy of Eventbrite still takes 2 minutes or 3 minutes sometimes. It has to boot 30 or 40 containers, and that takes a while and can be slow. And one of the things, we have that dependency tree, so I need to write an algorithm that just works out all the things that are siblings but not dependent, so you can just start those in parallel as you go down the tree, basically. So start this one, then start these two that depend on it, then start these three depend on those two, and just sort of parallelize it, make it much quicker. And those are some of the things we want to do. It would be nice at some point to open source our code for Tug. Tug has always been written with an open source mindset. The repo is pretty much clear of all secrets. It doesn't just run Eventbrite. For a long time, it had Eventbrite baked into the source code, but about this time last year, I took a hammer to it and made sure that it builds both Eventbrite and Lanyard. So there's also a Lanyard Tug project now. So in theory, it's all open upable. We just haven't done the work to sort of sit down, vet it, and do enough documentation to release it yet. But that's what I would like to do as well. And there's a few other things, containers are becoming more and more part of the way we do stuff here. As teams make new services, they can just make a container now to support their service. If you want to run tests, have a container. It doesn't have to run all the time, but you can have it to run tests in. And people seem to have taken pretty well to the idea of these sort of disposable but predictable environments. For this small service that we don't use very much, but it still needs tests, we can just make this sort of little image, and then every so often boot it up, run tests, shut it down again, and that works pretty well. It has been somewhat painful sometimes. Some of our repositories and some of our requirements are very, very complex. There's hundreds of lines in our core requirements file, for example. And so it would be nice to find ways of perhaps building those as better caches. So we do have you can build with the pip cache right now, which kind of works, but also uses the space up and isn't amazing. So there's a lot of work there in not only speeding up the setup process, we can pull images, but also the build process, how to make actual builds faster. Because we have so many moving pieces that pretty much every day something changes near the top of a Docker file and I have to rebuild everything. But that's all that kind of stuff. And that's pretty much it. I've got some time for questions. Anyone else want to ask them? But thank you very much. What are we using SSH keys for? So access. Sorry? Right, but Docker exec doesn't work with building images. So when you're building our containers, you need access to pull. So for example, we have internal Python packages, right? All our internal code, there's something called ebcommon, has a lot of our code in it. If you want to pip install that inside a build process, obviously everything to do with that is secure. You can't talk to GitHub to get that package unless you've got an SSH key around. And so for that reason, you can build half the things without SSH keys, but a lot of the Python stuff in particular needs to, at some point during the build, clone a repo or download a file from somewhere that needs SSH key access. So that's why you need them. Yes?
Do you have
So the question is, do we have a good way to have PDB or IPDB in sort of a third-party library? The containers we have that you can shell into them. So you can do tug attach, and it Docker execs your bash shell into the container. And they also have you can run debuggers that way if you want to. So you can sort of circumvent the main style. So there's two different things. Tug attach will go into a running container with things running, and so you can attach if you want to. Or tug shell will boot it from scratch with just bash and won't start the process, so you can wrap it if you want to that way. But it is tricky. We do have a hook for, I forget which IDE it is, but one of the IDE's debuggers as well, that sort of like, it does a similar port forwarding thing to SSH where you can hook in that way. How do you put the breakpoint into the code? I mean, that's the trick, isn't it? You can always Docker. You can always either modify the code on the container in place. So like you can shell into the container and modify the container's code. It won't persist over the next rebuild, but it persists in that container. So that would work, for example. Or you could temporarily vendor the code and do it. But honestly, most of the code we use that has bugs in it is ours. So like a lot of third-party libraries are much more reliable. So it's kind of, it's rare that I do it. I'm sure other engineers have much better ways of doing this stuff. Yes. So the question is, how do you SSH into a running container? So Docker exec is a solution here. So Docker exec launches a executable in the already running container context. So it's not SSH, but it's equivalent. So you do Docker exec, you do -it to give it a TTY, so you can interact with it as a terminal, and then you can just say container name and then just bash. And a bash shell pops up, and it's talking to the running container you specified. So that's what the tug attach command I mentioned does. Like you put the name in it, it just runs Docker exec bash. Bam, you're in. Similarly, you can run anything you like inside the container, but generally bash is a good enough way to start playing around, and that's how you run management commands. Yes. So I didn't mention for everybody but me, basically, they run a very small Vagrant file. And the Vagrant is just a Docker host, basically. We couldn't use, unfortunately, Docker machine or anything like that. But it just sort of, it's a Vagrant that just has basically a couple of Git things set up. Emacs and Vim are installed for both of our sides of the war. And then it has Docker and a few tools and Tug installed. So like most people they do Fiji SSH, then you have the host machine, and then from there you can do Tug attach. But even then, if you configure it right, you can just, because Docker is all network transparent, you can just expose the Docker port directly to a host machine and just do Docker exec from the Mac, and it can route all the way through the host VM into the container if you do it right. One more there at the back. Yeah. So the question is about like our containers are stateless, so that's how do you do things like databases and persistence and that kind of stuff. Oh, it's gone away. It's an interesting question, and the answer to that is a thing called volumes in Docker. So volumes are the way that you say, this part of the file system is not stateless. It is actually persistent. And so, for example, on Postgres, varlib Postgres is made a volume. And so again, tug, our wrapper, the configuration files which containers say like, oh, this is a volume, and tug manages, it makes all those volumes mount to directories directly inside our Docker like checkout copy. So you can just say, it's like, you can get volumes, MySQL-core, and then you immediately have all the tables right there. You can just access them from your editor. So that's how we do it as well. In production, you do a similar thing, but generally you would put the volume somewhere more reliable. Docker can use remote volumes, for example, these days. So you say like, oh, your volume is this remote disk over here and forward over. But there's a lot of options, but they have thought about this. It's not just throw everything to the wind. Cool. Thank you very much.